Right, question number 42. Question number 42. A number of capacitors each of capacitance no, just a minute, just cancel this, write down question number question number 45. Two capacitors of capacitance 3 microfarad, two capacitors of capacitance 3 microfarad and 6 microfarad are charged to a potential of 12 volt each. Charged to a potential of 12 volt each. They are now connected to each other. In such a way that positive plate of each joined with the negative plate of the other, What is the potential difference across each of the capacitors now? What is the potential difference across each of the capacitors now? Option A 4 volt, option B 6 volt, option C 0, option D 12 volt. See, whenever they are joined in this way, both the capacitors are parallel to each other. So in parallel combination of two capacitors, what is the common potential? V equal to C1 V1 plus C2 V2 by C1 plus C2. But remember, when so it will be V equal to C1 V1 plus C2 V2 by C1 plus C2. But now join the diagram first. Just complete the diagram. These are not connected in this way, such that you can find this by this method. They are connected like this. So second one is in opposite direction with the first one. So higher minus lower. So this one will become minus. This one will become minus because it will send its polarity is opposite, because it is given that positive terminal of each plate is connected with the negative terminal of the other. Because if you consider that in a normal way, then two positive terminals are connected, two negative terminals are connected. So here one is in this way, another is in the opposite direction. So that's why the equivalent will be minus C1 V1 plus C2 V2 divided by C1 plus C2. You can also write C1 V1 minus C2 V2. In that case, there will be a minus sign only. So now calculate. C1 V1 given, C2 V2 given. Now calculate. both the sign will be plus if the polarity on the both are positive on the left, both are negative on the right. Then it will be C1V1 plus C2V2 by C1 plus C2. But here polarity is reversed for this other. So that's why minus C1V1 plus C2V2 by C1 plus C2.
So what will be the value of V2?
V2 given, that is also 12. Both are, each is given. Both are individually charged to 12 volt. Okay. Two capacitors, one of capacitance C, and other two capacitors, one of capacitance C, two capacitors, one of capacitance C and other of capacitance C by 2. Two capacitors, one of capacitance C and other of capacitance C by 2 are connected to a battery of voltage V. The diagram is given. This is C, this is C by 2. The work done in charging both the capacitors completely, the work done in charging both the capacitors completely is option A 2CV square, 2CV square, option B 1 by 4 CV square, option C 3 by 4 CV square, option D half CV square. First calculate the equivalent capacitance and then use half into C equivalent into V square. These two are connected in parallel, so their equivalent will be C plus C by 2, that is 3C by 2. So C equivalent equal to 3C by 2. Then potential energy stored equal to half C equivalent, and across both of them potential remains same. So it will be half into 3C by 2 into V square, that is 3C by 4 V square. Floating in vacuum, near a large charged plate having total charge 1000 E, having total charge 1000 E and area of cross section and total area capital A. Okay, the plate is placed over the earth surface. Plate is placed over the earth surface. Over the earth surface. From this data, estimate, find an expression for the mass of the electron. Find an expression for the mass of the electron and find the direction of electric field of the plate and the direction of electric field of the plate. The magnitude of the charge of the plate is given, but not the direct sign is given.
So can an electron float in vacuum?
Definitely.
So how can it float?
Think, how can it float? Don't say that electron will sink in water. Different type of floating. Who said that water is only kind of fluid? There are many kind of fluid. Even there are certain kind of fluids which we cannot visualize. Field of the plate. See, electron is under two forces. Electron is under two forces. If they balances, then electron can float. What are the two forces on the electron? One is gravity, another is the force exerted by the charged plate. So if these two forces balances, then electron can float wherever it is placed near the plate. You have solved this type of problem where the charge, amount of the charge is asked to measure. Here I convert this and said that find the mass of the expression for the mass of the electron. See, due to its weight, electron is pulled by earth towards downward direction. So if the plate can exert a force on the electron in the upward direction, then there is a chance that these forces may balance each other and electron is feeling zero force. Zero force means it will float. Because you know that in case of condition for floating, when we study hydrostatics, the condition for flotation is that net force is zero. Because weight and buoyant force balances each other. So here instead of buoyancy, the force is given by the electric field. See, this one is the charged plate. Okay, so it contains certain amount of charge, say Q. Q is given 1000 times E. Okay, now electron is here, suppose this is earth below, so electron is experiencing a force mg, and if this field can exert a force in the upward direction F, and if these two forces balances each other, then the electron is feeling zero force and it can float near the plate. So from that condition we can write F should be equal to mg, and this F can be written as Q times E, that is charge of the electron, E times E. Charge of the electron is E, and field is created by this plate. So E times E should be equal to mg. Now this E, its area is given. So for an infinitely large plate, it is very large. It is mentioned in the problem that with respect to the electron, this plate is almost infinitely large, because electron means a very tiny particle. So with respect to that, we can consider this large plate almost infinitely extended plane. So in that case, near this plane, what is the expression for the field? Sigma by 2 epsilon naught. Now sigma means total charge of this divided by area. So that is Q by A epsilon naught, there is a 2, that is equal to mg. Now what is Q given? 1000 E. So substitute. So it will be 1000 E square divided by 2A epsilon naught mg. So this is 500. Now you can also place that this m equal to g equal to 10. So I can cancel this, and I can write here m equal to 50 E square divided by A epsilon naught. This is the expression for the mass of the electron. This is 1000 E square, so we cancel 1, 2, this is 500, this is 500 and 10. 1 0 is cancelled, so it will be 50 E square by A epsilon floating. Okay. Write down one more question. A positively charged sphere is connected at the one end of a silk thread. At the one end of a silk thread, which is attached to a point in the ceiling, which is attached to a point in the ceiling. Okay. If the charge on the sphere is small q and mass of the sphere is small m, and it is present in an electric field, in a uniform electric field. It is present in a uniform electric field (3 I cap plus 4 j cap inside bracket. Both of these are inside bracket. Newton per coulomb. Then find the angle made by silk thread with vertical, find the angle made by silk thread with vertical at equilibrium. See, initially if there is no electric field, then the bob is hanging vertically down. But if this electric field is present, the equilibrium point shifted in any direction. So at that moment, what is the angle the silk thread will make with vertical line? That you have to calculate. 53 কি উঠিও তো বলা নেই, 53 এলো কি করে? Expression আসবে, means some trigonometric function inverse of tan inverse or sin inverse, like this. The answer should be in terms of the given quantities, that is mass, electric field components, you can also use the charge and acceleration due to gravity g. Don't involve in new variables in the final calculation. You can use new variables, but that should be eliminated when you are calculating the final expression. Actually, this question is not given to see the final answer. What will be your approach? I want to check that. First write the equations and show me what are the equations. What? This one problem? Wait. This shows only one thing, you forget vector. Forget all the things of the vector resolution. आएगा वेट करो. देखो see, suppose this is the ceiling from which this one is the vertical line, and I consider that this mass is here. Now why in this direction, why not in this direction? Okay, I can consider that one force is acting on this mass downward, that is mg. Another force is acting along this direction, that is t. And one more force is there along the direction of the field, because this mass is carrying a positive charge. And if the field is E, then what is the force? Q into E. That should be along this direction, because vector E is given 3i cap plus 4j cap, means it should be directed between x and y in the first quadrant, like this. Okay, because if you have a coordinate system, then 3, 4, so this is the direction of the field, so it will feel an electrostatic force along that direction. Now if I divide t into two components, if this angle is theta, this angle theta, so this is t cos theta and this is t sin theta. Now mg is also in y direction, so no need to split it into components, but qe is not along any particular direction, so you have to split it into component, x component and y component. And how we can split mg into two components? See, there is one component, there is other component. Should it be qe cos theta? No, because this angle is not theta, this angle theta. Then what we will do? We will write its components, q into ex, and this one is q into ey. It is split, e is given in this format, exi cap plus ey j cap, where this is 3i cap plus 4j cap. Okay, so already given in the component form, so only we have to write the components along their respective directions, that is QEX and QEY. Now for equilibrium, horizontal equilibrium says T sin theta will be equal to QEX, vertical equilibrium will say T cos theta plus QEY equal to mg. Then you can write T sin theta by T cos theta, that is equal to QEX by mg minus QEY. So we get tan theta equal to, Ex means 3, so it is 3q divided by mg minus 4q. Now theta equal to tan inverse of this expression. Okay. In other types of problem, in most of the problem it is given that field is along this direction. Then we consider this is T, this is mg, and there is QE. Directly you can write QE here. But here it is given that the field is oblique. So we have to split field, force due to the field, into two components also. If it is given that two silk thread, they are carrying two charged spheres, then obviously one sphere will repel each other, and as a result this electrostatic force only along this direction. It has no this kind of oblique situation. So wherever the field is given, write the force accordingly, and remember that field is a vector quantity. Until the field is along the horizontal direction, you cannot set the entire force due to field along the horizontal direction. Whatever be the direction of the field, in that direction the force acts, and you have to split the electrostatic force into components. Okay. So if it is horizontal, then the problem is much more easy. We can only split T into components, and in that case electrostatic force will be equal to T sin theta and gravitational force equal to T cos theta, and you can simply find the answer. But in this type of situation you have to split all the forces which are not along any particular direction. Here T is not along x axis or y axis, and QE is not along x or y axis, both of them are oblique. Only mg is falling along y axis. So we split the two forces which are oblique to the coordinate axis.
So theta is taken from that side.
Yes? Theta, this one.
So what about from that side?
From that side means? With respect to the vertical it is asked. If you take from this side, then it is with the horizontal, na? Question number 5. A hollow cylinder has a charge. A hollow cylinder has a charge Q coulomb inside it. If phi is the electric flux through the electric flux coming out through the, if phi is the electric flux coming out through the curved surface Then find the flux coming out through one of the flat surface of the cylinder. Option A, 1/2 bracket starts 1/2 first bracket q by epsilon naught minus phi bracket close. One by two q by epsilon naught minus phi. Option B, q by 2 epsilon naught. Option C, phi by 3. Option D, q by epsilon naught minus phi. You have to find out the flux coming out through one of the flat surface. It's option 1. How much charge is enclosed by the cylinder? Q. So if this is a cylinder, so we consider this surface is A, this curved surface is B, and this is taken as C. So can I write that phi A charge is inside? So phi A plus phi B plus phi C, that is the total flux. That is equal to q by. Now through curved surface flux coming out is given, that is given as phi, and we can say that through surface A and through surface C same amount of flux will come out. So we can say that flux coming out through A and C are equal, and so we write both as phi A plus phi B is phi equal to q by epsilon naught. Then what is phi A? Q by epsilon naught minus phi 1/2. Through the curved surface flux is mentioned as phi. So total flux is phi A plus phi C plus phi B. Phi B is given as phi, and phi A and phi C are equal. So we have 2 phi A plus phi equal to q by epsilon naught from Gauss's theorem. Then phi A, that is through one of the flat surfaces, will be half into q by epsilon naught minus phi. Okay.
So, explain the question once again. Explain the question.
This question, see, it is given that there is a cylinder. Inside that cylinder there is a charge. So what will be the flux coming out through the cylinder? From Gauss's theorem it says that if the charge is enclosed, flux coming out will be q by epsilon naught. So through this cylindrical surface, how many individual surface through which flux can come out? Through surface A, through surface C, and through curved surface B. So phi A plus phi B plus phi C, all the fluxes will become sum equal to q by epsilon naught according to Gauss's theorem. Now through curved surfaces flux is coming out, it is mentioned as phi in the problem. So phi B equal to phi I put, and we know that then two other surfaces are equal area, so flux coming out through them are also same. So we can write 2 phi A plus phi B, because phi C is also phi A. Phi A plus phi A, 2 phi A plus phi equal to Q by epsilon naught. Then what is phi A? That is the flux through any of the flat surface. Question number 7. When n identical mercury droplets, when n identical mercury droplets when n identical mercury droplets charged to the same potential V, charged to the same potential V, combine to form a single drop, combine to form a single drop, the potential of the new drop will be option A V by N, option B n to the power 1/3 V, n to the power 1/3 into V, option C NV, option D n to the power 2/3 into V. See, for a single droplet, the potential V equal to 1 by 4 pi epsilon naught Q by R, suppose. So when n such droplets combine together, then we can say that volume of such droplets will be, total volume of n such droplets will be 4/3 pi small r cube, which is equal to the volume of the bigger droplet formed, 4/3 pi, say capital R cube. Okay, so n such drops when combined together, the total volume will remain unchanged. So n number of small droplets volume will be equal to the single big drop's volume. Clear? So from that we can find a relation between their radius. 4/3 pi will cancel. So we can write capital R will be equal to n to the power 1/3 smaller. This is my first relation. So when all such n droplets combine, then their total charge also combines. So new droplets total charge, if capital Q, then this will be n times small q, because charge is conserved. So total amount of charge is nq. So that is the total charge of the bigger droplet. Now if I calculate the big droplet's potential, so it will be 1 by 4 pi epsilon naught capital Q by capital R. So just put 1 by 4 pi epsilon naught, capital Q means n times small q, divided by n to the power 1/3 small r. So n by n to the power 1/3, it will be n to the power 2/3, and remaining term 1 by 4 pi epsilon naught q by r, that is equal to V. So option D is correct. So when the droplets combine to form a single drop, then their radius is modified, new radius will be changed. Not only that, the total amount of charge possessed by the big droplet is also changed. It will now be nq, and radius will become n to the power 1/3 r. So you cannot consider only the change in radius, you have to also consider that the total charge joins, so the total amount of charge increases. Write one more problem. Infinite number of point charges, each of plus q. Infinite number of point charges, each of plus q, is present on the positive x-axis at points x equal to 1, 2, 4, 8, 16, dot dot up to infinity. Find the potential for them at the origin. Find the potential for them at the origin. Acha, write down options. Option A, KQ, KQ. Option B, 2KQ. Option C, 0. Option D, infinity. Suppose this is the origin, this is x equal to 1, x equal to 2, then 4, further 8, and so on. Charges are placed at these points, each of plus q. Q, 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 Q. So you have to calculate the field at x equal to 0 origin for them. Then for the first charge, field potential at this point is kq by 1, kq by r. So kq by 1, we consider all units as SI unit. Then next one is kq by 2, then kq by 4, kq by 8, and so on up to infinity. Then kq common, you can write this one as half 1 plus half plus 1 by 2 square plus 1 by 2 cube, and so on. So this pattern shows that it is an infinite GP series with common ratio r equal to half and first term 1. That is like AR square, AR cube, and so on. This is the standard result of the GP, sum of the GP series. If there are infinite number of terms in a infinite GP series, infinite number of terms in a GP series, and common ratio is less than 1, then sum will be A by 1 minus R. On the other hand, if it happens that first term is A and common ratio R is greater than 1, then the sum will be A by R minus 1. Okay. So if there is an infinite GP series having common ratio less than 1, then sum will be A by 1 minus R, and if having common ratio greater than 1 for infinite GP series, sum will be A by R minus 1. Clear? So now from this we can write it is directly kq into 1 by 1 minus half that is 2, so it will be 2kq. So this infinite GP series formula you have to remember. Two charges plus q and minus q are placed at points A and B respectively. Two charges plus q and minus q are placed at a point A and B respectively, which are at a distance 2L apart. Which are at a distance 2L apart. C is the midpoint between A and B. C is the midpoint between A and B. The work done in moving a charge plus capital Q. Previous charges are small q. The work done in moving a charge plus capital Q along a semicircle CRT. Question is not complete. Just a minute. Question is not complete. Half question is missing, I think. They are giving along a semicircle CRD. What is R, what is D, that is not mentioned. But write down question number 9. Cross this one. 9. No, question number 10. Write down. The electric potential inside a charged spherical ball. The electric potential inside a charged spherical ball is given by V equal to A r square plus B, small a, small r square plus small b. A and B constant. A r square plus B. A and B constant. Where small r is the distance from the center. Small r is the distance from the center. Then the charge density inside the ball is option A, minus 3a epsilon naught r, minus 3a epsilon naught r. Option B, minus 6a epsilon naught. Option B is minus 6a epsilon naught. Option C, 3a epsilon naught r. epsilon naught r. And option D, 0. See, it is given that volume V equal potential V equal to A R square plus B. Okay, potential, I denote potential by capital V. This is equal to A R square plus B. So from that calculate differentiation dV dr. Then it will be 2AR. Then take minus on both sides. Then minus dV dr means electric field. So this is minus 2AR. Okay. Electric field is minus 2AR. Negative derivative of potential is field. Now come to Gauss's law. Gauss's law says that this is a spherical surface, so E into surface area 4 pi r square is the flux coming out through the sphere. That is equal to Q by epsilon naught. So it can be written as 1 by epsilon naught into charge density rho into volume. Four by 3 pi r cube. Charge density into volume will be total charge enclosed. Now put the value of E. That will be minus 2AR into 4 pi r square equal to rho by epsilon naught into 4 by 3 pi r cube. So 4 pi cancel, r square r cube cancel. So rho will be equal to minus 6A epsilon naught. That is the answer. So from the given formula for V, first calculate electric field and then use Gauss's theorem that electric flux coming out of a closed surface equal to charge enclosed by epsilon naught. So since it is spherical, so charge coming, electric field is constant over all points, so no need to integrate. So directly write E into 4 pi r square is the surface area of the sphere through this is the entire flux, and according to Gauss's theorem that is equal to 1 by epsilon naught times Q enclosed. But now Q enclosed equal to charge density into volume. So charge density rho and volume of the sphere of radius r is 4/3 pi r cube. So I put it directly. Okay. Two charges Q1 and Q2 are placed 30 centimeter apart as shown in figure. A third charge Q3 is moved along the arc of a circle of radius 40 centimeter from C to D. The change in potential energy of the system is Q3K by 4 pi epsilon naught. Q3K by 4 pi epsilon naught, where K is, here K is not 1 by 4 pi epsilon naught, K is a different thing, where K is option A 8Q2, K is option A 8Q2, option B 8Q1, option C 6Q2, option D 6Q1. This is the diagram. A is there, B is there, and it is moving along this path, C to D. This up to this 30, then remaining part 40. So this is 40, this is at a distance 30 from the origin. They are not at equal distance. You have to calculate potential energy at D and minus potential energy at C. Okay, so initially the Q3 is here at C, so you can calculate potential energy at C. When it comes to this point, then calculate the potential energy at D, then calculate UD minus UC. Okay, that is equal to the given expression Q3K by 4 pi epsilon naught. From that you have to find out K. Okay, with this question, go to sleep. Entire night think about how to solve, and then after 1 year we will solve.